Hello and welcome back to the deep dive. So today, we're kind of gonna ruin a magic trick for you.
Oh, I like the sound of that.
You know that moment, right? You type a prompt into a chatbot, maybe you ask it for, I don't know, a summary of some dense report.
Or a poem about a toaster.
Yeah, a poem about a toaster in the style of Shakespeare. And then poof, it
It
appears.
feels instant.
Totally instant. Effortless.
It feels like magic.
Yeah.
But, as we always say, magic is usually just really, really good engineering hidden behind a curtain.
Exactly. And today, we are ripping that curtain down. We're completely ignoring the flashy part, the text generation, the image creation, and we are looking at the hidden plumbing that makes it all possible.
The messy part.
The very messy part. We're talking about this industrial complex of data engineering that happens before the model ever even sees a single word of your prompt.
Yeah, it's the unglamorous reality, isn't it?
Yeah.
Everyone wants to talk about the model. Is it GPT-4? Is it Claude? Is it Llama?
Right.
But if you talk to the actual architects who are building these systems, they spend, maybe 20% of their time on the model?
And the other 80%?
What we're talking about today, the pipeline.
The pipeline. It sounds so ominous. But based on the stack of sources we've got in front of us, which focuses on, and I'm quoting here, foundational data engineering for multimodal model input.
Which is a mouthful.
It is a mouthful, but it seems like this is actually where the war is won or lost.
Completely. You can have the smartest, most expensive foundation model in the world. You can pay millions for the compute.
Mm-hmm.
But if you feed it garbage or even just, slightly disorganized information, that expensive brain is going to hallucinate. It's going to drift.
It's going to give you confident lies.
Exactly. Confident, plausible, and utterly wrong answers.
I was trying to think of an analogy for this, and the one that kept popping into my head is a really high-end restaurant.
Okay.
You go to a Michelin star place, and the plate that arrives at your table, that's the AI output, the generated text.
Yeah, it's a beautiful final product.
Yeah. But that meal is only as good as the ingredients they have in the pantry, and more importantly, how those ingredients were prepped.
That's a perfect analogy. Absolutely perfect. Because if the tomato is rotten, it doesn't matter if the chef is a world-renowned genius.
The sauce is going to be bad.
The sauce will taste like rot. In our world, the ingredients are your data. And the prep work, the chapping, the peeling, the washing, checking for bugs. That is data engineering.
So that's our mission today. We are going to unpack all of this prep work. We're going to look at 3 big buckets: data validation, multimodal processing.
Which is just a fancy way of saying dealing with stuff that isn't just text.
Exactly. And input preparation.
And for you listening today, whether you're an engineer prepping for like a system design interview, or maybe you're a product manager just trying to figure out why your bot keeps failing, we are going to get into the nuts and bolts. We are not just going to say, clean your data.
No, we're going to talk about how, which tools, what format, what does the actual JSON payload look like?
Right. The nitty-gritty.
The source material has this very specific goal stated in its overview note. It says the goal is reliable, high-quality inputs that reduce errors and variability.
And variability is the key word there. It's the silent killer.
What do you mean by that?
Well, variability is the enemy of any kind of enterprise software. If I ask the AI a question on a Tuesday and I get a great answer,
Okay.
but then on Wednesday, the data format from some upstream system shifts slightly, and now the AI breaks or gives me a wrong answer, that system is useless in a business context.
That's not reliable.
It's not reliable, and that reliability comes from the pipeline, not the model.
Okay, so let's map out our journey for this deep dive. We have 4 main pillars to get through.
Lay it on us.
First, the bouncers at the door validation. Then, the multimodal challenge, which is how we handle that fork in the road between text, images, and audio. Third, the Polish using tools like entity extraction to make the data even smarter.
And finally,
The handshake, how we format everything so the model actually accepts it and understands what we're asking.
and we're going to do something a little different today, right? We're not just going to talk about it.
That's right. We're going to run a simulation. The source material has these great practice prompts.
Yeah, they're really good.
So instead of just describing the tools, we're going to conceptually build a pipeline together live.
I love it. Let's put on our hard hats.
All right. Section 1, data validation workflows. The first line of defense.
Okay, so let's start with the why.
Yeah.
The source says to implement data validation for FM consumption. Now, play devil's advocate for me here.
Okay, I'm ready.
These models have read the entire internet. They've seen messy HTML. They've seen broken code, bad grammar, you name it. Why can't I just dump my messy corporate data into the system and let the AI figure it out?
Yeah, that's the million-dollar question.
That's true.
Literally.
Yeah.
Because my first thought is, isn't the AI smart enough to know that, hey, this file's just garbage?
It might be smart enough to know it's garbage, but it will still charge you to read it.
Ah.
Hmm.
It always comes back to the economics.
Always. Foundation models, especially the big ones hosted on platforms like Amazon Bedrock, they usually charge by the token.
And a token is like what? Part of a word?
Roughly, yeah.
Huh.
Think of it as a small piece of text. Every single thing you feed that model, every word, every character, costs you money. So if you have a data set of, say, 10,000 documents,
Okay.
and 2,000 of them are corrupted files or blank PDFs or just a string of random characters because of a bad expert from some old system,
You are paying to process noise.
you are literally lighting money on fire.
Hmm.
But it's actually worse than just the cost.
How so?
It's what that called the insanity factor. AI models have this compulsion to complete a pattern.
Yeah.
If you feed it a string of nonsense, it might try to make sense of it. It might hallucinate a meaning that simply isn't there. It's trying to be helpful, but it's working with garbage.
So bad data doesn't just give you an error message like old software would.
Not always.
It gives you a wrong answer that looks right.
Precisely. And in a business context, a confident lie is so much more dangerous than a system crash.
I can see that. A crash, you know something's wrong. A lie, you might make a terrible business decision based on it.
That's it. So validation is the firewall. It ensures that only data that is worth paying for actually gets to the model.
Okay, so let's get into the toolkit. The source lists a specific set of tools. AWS Glue Data Quality, SageMaker Data Wrangler, custom Lambda checks, and CloudWatch.
Right.
To an outsider, those might sound like they all do the same thing.
Yeah, they do overlap for sure, but they sit at different altitudes. They solve different parts of the problem.
Okay, let's break them down. Tool number 1, AWS Glue Data Quality. What is it?
Okay, think of Glue as your automated industrial scale sorting machine. It's serverless, which is great.
So you don't have to manage the infrastructure.
Nope. You just define a set of rules. We call this DQDL, which stands for Data Quality Definition Language.
Give me an example of a rule. What would I write?
A simple rule might be, like, column A must never be empty, or column B must be a valid email address.
Okay, that's straightforward.
But it can get more complex. A rule might be, the transaction date must be within the last 5 years, and the total value must be a positive number. You can chain these conditions together.
Got it. So you set these rules, and what does Glue do?
It just scans. It can scan millions, even billions of rows of data automatically. And if a row violates one of your rules,
What happens?
gets quarantined, kicked off the conveyor belt immediately. It never moves downstream to the more expensive parts of the pipeline.
So this is for bulk processing. It's the big brute force filter at the start.
Correct. It's checking the structural integrity of your data at massive scale.
Okay, now compare that to the next one. SageMaker Data Wrangler. The name suggests something a bit more hands-on, cowboy style.
It is a bit more hands-on. Wrangler is a low-code visual tool. That's the main difference.
What does that mean in practice?
Well, Glue gives you a pass-fail report. It'll say,
Mhm.
10,000 rows failed this rule. Wrangler, on the other hand, lets you see the shape of the data.
What do you mean by shape?
Imagine you load your data set. Wrangler will instantly generate histograms for you. It'll show you a distribution graph. You might look at it and say, wait a minute, why is there a huge spike of customers claiming to be 150 years old?
Ah, I see. Glue might miss that if I didn't explicitly write a rule that says age must be less than 120.
Exactly. You wouldn't think to write that rule. But Wrangler shows you the outlier visually. It helps you spot the weirdness, the outliers, the missing values that shouldn't be missing.
So it's more of a detective tool.
It's a detective tool, and it allows you to build a recipe for cleaning. You can just click and say, drop these rows, or fill these empty values with the average or 0. You visually construct the cleaning pipeline.
Okay, I like that analogy. Glue is the bouncer checking ID at the door. Wrangler is the detective in the back room analyzing the crowd for suspicious characters.
That works. That's a good way to put it.
Then we have custom Lambda checks. Now, I know Lambda is basically just code execution on demand. Why do we need custom code if we have these fancy visual tools like Glue and Wrangler?
Because the real world is messy and specific.
Always.
Glue checks for generic data quality. Is it a number? Is it a date? But every single business has unique, arcane logic that no off-the-shelf tool could ever know about.
Okay, give me an example.
Let's go back to our law firm analogy. You're processing contracts. A contract is a valid PDF, so it passes all the technical checks.
Right, Glue would say it's fine.
But maybe your firm has a very specific rule. We only process contracts that have a countersignature on the last page.
Glue has no idea what a countersignature is or even what a page is.
Exactly. It just sees a blob of data.
Yeah.
So you write a small Python script, you put in a Lambda function, and that script opens the PDF, maybe uses a library to look at the last page, and it checks for that specific digital signature block.
And if it's missing.
It rejects the file. It puts it in a needs manual review bucket.
So this is the specialized guard, the one who knows the secret handshake.
Yes. It's for enforcing the business logic that the generic tools can't cover.
And watching all of this, the final tool, CloudWatch metrics.
The eyes in the sky.
The CCTV for the whole pipeline.
You absolutely cannot build a pipeline and just walk away. It's not a set it and forget it thing.
Why not?
Data drifts. Systems change. Maybe the vendor sending you the files changes their export format on a Monday morning without telling you.
Oh, that's the nightmare scenario.
It is. Because suddenly your custom Lambda function starts rejecting 100% of the files.
And if you're not looking...
Silence is the worst failure mode. If the system crashes, you get an alarm. But if the system just silently rejects everything, you might not know for days that no new data is coming in.
And CloudWatch is what screams at you.
CloudWatch is what screams. You set an alarm that says, hey, the moving average of ingested documents is normally 10,000 an hour. The last hour was 0. Something is very, very wrong. It's your early warning system.
Okay, let's apply this. Let's do the practice prompt from the source. It says, design a validation pipeline for documents before they are embedded and indexed.
Let's do it.
Let's build this live. Let's say we're building an internal search engine for, I don't know, a massive engineering firm. They've got blueprints, technical specs, PDFs, CAD files, all coming in from all over the world.
Okay, that's a nice, messy, heavy data set. Let's build the gauntlet for it.
Step 1. The files arrive. Let's say they all land in an S3 bucket. That's the cloud storage. What happens first? What's the very first touch point?
So the first thing I would do is trigger a Lambda function right at the gate, as soon as the file lands, before we even try to look at the content.
Why Lambda first? Why not Glue?
To check basic file integrity, is this actually a PDF? Or did someone rename a JPEG? Is it corrupted? Is it password protected?
The password protected one is huge.
It's a silent killer. Because if it is password protected, we can't read it anyway, so we reject it immediately. Fail fast, don't waste money passing a locked file to the expensive downstream processing tools.
Smart, very smart. Okay, so the file's unlocked. It seems to be a valid file type. It's not corrupted. Step 2.
Okay, now another Lambda function could maybe extract the raw text and any metadata. Then we pass that extracted text to AWS Glue data quality.
And this is where the rules kick in.
This is where we apply the content standards. Is the text in English, as expected? Does it meet a minimum word count? If a technical spec has only 3 words in it, it's probably a mistake or a blank page.
What about sensitive info? That's a big one for an engineering firm. Trade secrets or PII.
Great point. Glue is really good at pattern matching. So you can have a rule that checks for PII patterns, social security numbers, credit card numbers, things that should never be in these docs.
What does it do? Delete them?
It could trigger another process, it could flag it for review, or it could trigger a redaction job that scrubs that info out before it ever gets indexed.
So we've confirmed the file works, we've confirmed the content is valid and safe.
And then step 3, CloudWatch is recording all of this. Processed 1 file, success, or processed 1 file, failed, PII detected. You're logging everything. And only then, and this is the really crucial part, only then do we allow that clean, validated data to move on to the next stage, which is the embedding model that turns it into vectors for the search engine.
It really is a gauntlet. By the time the data gets to the AI part, it's already survived 3 or 4 assassination attempts by the validation layer.
And that is why the search engine will actually work, because the index isn't polluted with garbage files and bad data.
Okay, so that covers text documents really well. But the source material throws this massive curveball in section 2.
Yes, it does.
It says we need to deal with the multimodal challenge.
The fun part.
The fun part. Multimodal processing, text, images, audio, and tabular data. This complicates things significantly, doesn't it?
Massively. When we were just talking about text, it was a nice linear path. But multimodal implies that our pipeline needs to fork. It needs branches.
Because you can't pipe an MP3 audio file into a text analyzer.
It'll just see binary noise. It won't know what to do.
Yeah.
The pipeline has to be smart enough to say, This is a .wav file. It goes down the audio path. This is a .csv. It goes down the tabular path.
And the source specifically mentions pre-processing for bedrock multimodal models. So we're not just doing this in a vacuum. We're prepping data for very specific, powerful models like Claude 3 or the Titan multimodal model.
Exactly. The prep is often tailored to the model's specific input requirements.
Let's talk about tabular data first. Spreadsheets, databases,
Yeah.
rows and columns.
The most common form of business data in the world.
Why is this a challenge? It seems so organized. It's already structured, right?
It's structured for a computer database, yes.
Yeah.
But it's not structured for a large language model. You have to remember how an LLM thinks.
Which is how?
It reads text. It reads sentences, paragraphs, stories. It reads left to right, top to bottom. It's looking for narrative and context. Now, if you feed it a raw CSV file, separated values, it often loses track of the context from row to row. Imagine a single row that just says, Smith, 50,000, 12, true.
To me, that's just a list of random values. I have no idea what that means.
Exactly. And the model might struggle to know that 50,000 is a salary, 12 is years of tenure, and true means they are an active employee. It doesn't have the schema header in its memory for every single row it processes.
So what's the fix? How do we pre-process that?
We use a technique called serialization, or sometimes you'll hear it called semantic expansion.
Sounds fancy.
It's pretty simple in practice. We write code in the pipeline, another Lambda function probably, to translate that row into a natural language story.
A story from a row in a spreadsheet.
Yes. We convert Smith, 50,012, true, to a full sentence. Something like, the employee named Smith has a salary of $50,000, a tenure of 12 years, and their active status is currently true.
Wow. Okay, so you are literally translating Excel into English.
That's exactly what you're doing. You're giving the model the context explicitly in every single record.
Mm-hmm.
This reduces hallucinations significantly because the model doesn't have to guess what column 3 represents. It's told right there in the sentence.
That makes so much sense. It seems so obvious once you say it.
Right.
Now, let's go to the heavy stuff. Video and audio.
Mm-hmm.
The source asks us to, and I quote, define each pre-processing step from raw input to FM-ready format for a multimodal use case.
Let's pick a hard one. Let's go back to that engineering firm. Let's say we have hours and hours of drone footage from construction sites.
Okay.
And we want to be able to ask the AI, show me all the footage where the concrete foundation has a visible crack in it.
Okay, that is a heavy lift. The raw input is a video file, an MP4.
Right. Now, a video file is actually a container. It holds at least two things, a visual stream and an audio stream. So the pipeline has to split immediately.
The fork in the road.
The fork in the road, path A audio. We use a tool to strip the audio track out of the video file. We run that audio through a transcription service like Amazon Transcribe.
And that gives you a text transcript.
It gives you a transcript of what the drone operator, the site inspector, was saying. Okay, now looking at the north sector. Looks like there might be a hairline crack here.
So you turn the sound into searchable text.
But that text is raw. It has ums and ahs and maybe technical jargon, so it might need a secondary pass to clean it up or define acronyms. That's the audio branch.
Okay, so audio becomes text. What about the visual branch, path B?
We can't feed a 20-minute 4K video file into most models directly yet. It's just too many tokens. It's too much data.
Yeah.
It would crash the context window.
So what do we do?
We use a process called frame extraction.
What's that?
We basically sample the video. We turn the movie into a slideshow.
Okay.
Maybe we take one screenshot every 5 seconds. Or, if we want to be smarter, we use an algorithm that detects scene changes and only takes a picture when the camera angle shifts significantly.
So you're not just grabbing thousands of identical frames.
Exactly. You're looking for the meaningful moments. So now, instead of the video file, you have a pile of JPEGs.
A big pile of JPEGs.
A big pile. And we probably need to resize them, normalize them to a standard resolution like 1024 by 5024 pixels so the model doesn't choke on a massive file size.
And then do we recombine all this? The text from the audio, the images?
Yes. This is the FM-ready format the source talks about. It's a package. It's a structured object. We bundle the cleaned-up transcript from the audio, the stack of selected resized images from the video, and any other metadata, like the GPS location and the timestamp.
And you send that whole package to the multimodal model.
You send that package, and now you can ask it, show me images that match the description hairline crack from the transcript.
That's fascinating. The user thinks the AI watched the video. But in reality, the engineers in the background broke the video into 1,000 pieces, converted them, cleaned them, created a storyboard and a script, and the AI read that.
That is the illusion. And maintaining that illusion is a massive data engineering task.
Mhm.
If you skip a step, if you don't transcribe the audio, or you send blurry, oversized images, the AI is effectively blind and deaf to what happened in that video.
Okay, this is making so much sense. So we've validated the data, we've split it up by its mode. Now we move to section 3, the Polish. This is pre-processing to enhance quality.
Right. This is moving from the question, is the data valid, to, is the data good? Is it optimal for the model?
The source lists normalization and cleansing. We touched on this with the washing vegetables idea, but give me a really specific technical example of normalization that trips people up.
Dates. Dates are the absolute bane of a data engineer's existence.
Really? Why dates? They seem so simple.
Because humans are wildly inconsistent. In the US, if I write 0203-0026, what date is that?
That's February 3rd.
Right. In Europe, or the military, or most of the scientific world, that reads as the 2nd of March.
Right. Day month versus month day.
And if you feed a foundation model a huge data set that mixes these formats, it gets chronologically confused. It literally won't know the correct order of events. It might hallucinate a timeline that is physically impossible.
So normalization is forcing everything to agree on one standard.
Yes. In the pipeline, you write a step that converts every single date, no matter its input format, to the ISO 8601 standard YYYY MMDD. No ambiguity.
And this applies to other things, too.
Oh, yeah. Currency.
Yeah.
We're talking US dollars or Singapore dollars. You have to normalize it. Measurements, are we using meters or feet? You have to pick one and convert everything. Consistency is king.
Now, here's a specific tool mentioned that I found really interesting. Entity extraction with Comprehend.
Amazon Comprehend,
Yeah.
a very powerful natural language processing service.
Here's my question. Why are we using an NLP service to process text before we send it to an even bigger, more powerful NLP service, the foundation model? Doesn't that seem redundant? Why not just let the big brain do it all?
It's an excellent question. It comes down to two things: efficiency and retrieval. It's all about enabling RAG retrieval augmented generation.
Okay, explain ORGRE in this context.
Let's go back to our law firm. You have 1 million contracts stored. You want to ask the AI, what are the termination clauses for all contracts signed with Acme Corps in the year 2024?
Okay, a very specific business question.
Right. If you just rely on the foundation model, your first problem is, how do you even find the right documents to show it?
I guess I'd do a keyword search for Acme.
And you get thousands of hits, documents that just mention Acme in passing. It's messy, it's slow.
I see.
But if you use Comprehend during the ingestion phase, before you even store the document in your system, Comprehend scans the text and it says, hey, I found an entity of type organization and its value is Acme Corp. I also found an entity of type date and its value is 2024.
It's tagging the data. It's like putting little colored sticky notes on the folder.
That is exactly what it's doing. It extracts those key entities and stores them as structured metadata alongside the raw text. So now when you search, you aren't searching the full text.
You're filtering the metadata tags.
Exactly. You're saying, show me all documents where the organization tag equals Acme Corp and the date tag is in 2024. It's lightning fast and it's 100% accurate.
And then you hand those 5 very specific documents to the foundation model to read.
Correct. You use the small brain, Comprehend, to organize the library so that the big brain, the FM, only has to read the one relevant book, not wander through the entire building. It adds a layer of intelligence to the raw text.
Okay, now this next point in the source absolutely blew my mind a little bit. Reformatting with Bedrock.
Ah, yes. My favorite part.
So just to be clear, we are using Bedrock, which is the home of these big foundation models, to fix the data for the foundation models.
Here's where it gets really meta and really interesting. It's recursive AI. Sometimes, the best tool to clean messy, unstructured data is an AI itself.
How does that work in practice?
Traditional code like Python scripts or regular expressions is great for simple, predictable patterns. Find every email address, remove all HTML tags.
Right.
But what if you have a paragraph that is just poorly written, it's grammatically broken, it's full of slang, or it's just a set of unstructured notes from a call center agent's transcript?
You can't write a rule for make this sound professional.
Exactly. It's too fuzzy. But you can pass that messy paragraph to a cheaper, faster foundation model, maybe a smaller one like Amazon Titan or Claude Haiku, and give it a very specific instruction in the prompt.
What kind of instruction?
Something like, rewrite the following text into clear professional English. Do not change the meaning or add any new information. Just fix the grammar, spelling, and structure. Output only the corrected text.
So you have a junior AI cleaning up the data for the senior AI down the line.
Basically, yes. Or You can use an AI to summarize a very long document, and then you feed that summary into the final model to save on tokens. We're using the intelligence of the model to do the heavy lifting of data preparation that used to be incredibly difficult to automate.
It's AI all the way down.
It creates this virtuous loop of quality improvement. The better your pre-processing AI is at cleaning, the better your final output will be. It's turning noise into a clean signal.
That is fascinating. The tools are building the tools.
Correct.
All right, so we have it. We have clean, validated, multimodal, AI-polished data. It's gleaming. It is beautiful.
Okay.
Now, section 4, input formatting, the handshake.
The last mile problem of data engineering.
We can't just throw this beautiful data at the model and say catch. We have to wrap it up correctly. The source puts a lot of emphasis on input formatting.
Right. Because if you don't speak the language of the API, the model will not answer. It's like having the perfect key but putting it in the lock upside down. The door won't open.
Okay, the source mentions JSON payloads for Bedrock. For those listening who aren't developers, can you visualize a JSON payload for us? What is it?
So JSON stands for JavaScript Object Notation.
Right.
But forget the name. It's not important. Think of it as a standard form, or like addressing an envelope.
Okay, like a letter.
Exactly.
Yeah.
When you mail a letter, you can't just write the message on the outside of the envelope and hope for the best.
Right, there's a structure.
There's a structure. Return address goes here, destination address goes there, stamp goes in the corner. JSON is that structure for data. It uses key-value pairs.
So key, prompt, value. Write me a poem about a toaster.
Exactly. But the payload contains way more than just the prompt. It contains what are called the inference parameters.
What are those?
These are the dials that control the model's brain. The source mentions drafting a standard JSON request schema. This schema would include keys for the prompt, but also keys like temperature and top.
Let's unpack those. What is temperature?
Temperature controls randomness. Think of it as a creativity dial. If you set the temperature to 0, the model becomes a strict, boring account. It will always give you the single most likely, most predictable answer.
Good for math problems or writing code?
Perfect for that.
Oh.
But if you turn the temperature up to 1, the model becomes a freewheeling poet. It takes risks. It chooses less likely words. It becomes more creative, but also much more prone to hallucinations and going off the rails.
And top P, is that similar?
It's similar, yeah.
Yeah.
It also controls creativity, but in a different way. It limits the pool of vocabulary the model is allowed to pick its next word from. It's another way to dial in that balance between deterministic and creative.
So the JSON payload isn't just the question, it's the question plus a detailed set of instructions on how to answer.
Exactly. It's here's the data, and here is the personality I want you to adopt while you process it. And the engineering task is ensuring that every single request from your application follows this consistent JSON request structure.
And if you miss a comma.
Request fails. If you misspell maxto sample, request fails.
Yeah.
The API endpoint is a very unforgiving bouncer. It has to be perfect.
It's very strict.
Very strict.
Okay, one last formatting type mention that I think is crucial for so many applications. Conversation formatting for chatbots.
Ah, yes. This is where so many people get tripped up when they're building their first AI application.
Why is that?
Because people assume the chatbot has a memory.
Yeah.
They think, I'm talking to it. Of course it remembers what I said 10 seconds ago.
And it doesn't.
No, not inherently. A standard foundation model is stateless.
Yeah.
It has total amnesia. Every single time you send a message, it is the first time the model has ever met you.
Wait, hold on, explain that. Because if I'm chatting with ChatGPT or a customer support bot and I say, my name is Sarah, and then in the next message I say, what is my name? It answers Sarah. How did it do that if it has amnesia?
Because of the conversation formatting that's happening in the pipeline, to the code. When you ask, what is my name? The application, the plumbing behind the chat window, didn't just send that question to the model.
What did it send?
It effectively sent a transcript of the entire conversation up to that point.
Oh, so it sent something like, human, my name is Sarah, assistant, hello Sarah, how can I help you? Human, what is my name?
Exactly. It resends the entire history with every new turn. The data engineering layer has to stitch that history together, format it with special tags like role, user, and role, assistant, and then send the whole bundle again and again.
So the practice of formatting for chatbots isn't just sending the new question, it's managing the archive of the conversation.
Correct. And, critically, knowing when to cut it off. Because eventually, the history gets too long, and it exceeds the model's token limit or context window. So your code has to be smart enough to start deleting the oldest messages to make room for new ones.
And if you don't do this pre-processing, this history management.
You get a chatbot with severe amnesia.
Yeah.
And a chatbot with amnesia is a very, very frustrating customer service experience.
This brings us perfectly to section 5, the so what. We've gone through all the tools, the modes, the polish, the formatting. Why does this architecture matter so much?
Well, let's look at that overview note from the source again.
Hmm.
The whole point is reliable, high-quality inputs that reduce errors and variability.
Reliable.
If you don't have validation, you get errors. Plain and simple. Your application crashes because someone uploaded a bad file and you didn't catch it. Unreliable.
Right.
If you don't have normalization, you get variability. One user asks for sales data for a product and gets 50K. Another asks and gets 50,000.00. Third gets $50,000. That inconsistency makes it impossible to build any software on top of the AI. You can't build a dashboard if the numbers keep changing format.
It's unpredictable.
Totally. And if you don't have proper JSON formatting,
The system just breaks. It doesn't work at all.
the handshake fails.
It really seems like the role of the engineer is shifting, or maybe the spotlight is shifting to a different part of the engineering team.
I think that's a great way to put it. It's shifting drastically.
If you're listening to this and you're prepping for a meeting or learning this field, the takeaway seems to be AI is not just about the model. Everyone wants to talk about the brain.
The sexy part.
Yeah, the sexy part. But the pipeline is where all the work is.
I would argue the pipeline is the product. The model is becoming a commodity.
That's a bold statement.
Think about it. You can swap models. You can switch from Bedrock to another provider. You can upgrade from Claude 3 to Claude 4 with a one-line code change.
Yeah.
But your data pipeline, your unique validation rules, your normalization logic, your specific way of handling drone footage, that is your intellectual property.
That's the moat around your business.
That is the moat. That is what separates a cool weekend demo from a hardened, production-ready enterprise system.
So the foundation in foundation models isn't the model itself, it's the data engineering that supports it.
I could not have said it better myself. That's exactly right.
Wow. We have covered a massive amount of ground today. Let's just quickly recap our journey.
Let's do it. We started with the raw ingredients, often messy, mixed up, multimodal data.
We built a gauntlet of validation using AWS Glue and custom Lambda functions to kick out all the bad apples and, importantly, save money on tokens.
We then broke down the multimodal challenge, forking our pipeline to handle video frames and audio transcripts separately, turning everything into a format the model could read.
We polished that data using normalization to fix things like dates and currencies, and we even used AI itself via Bedrock to clean up messy grammar.
And finally, we packaged it all up in a perfect, strict JSON payload, making sure the handshake with the model was flawless every single time.
It's a total transformation from chaos to structure.
It is. We're in the business of turning the noise of the real world into a clean signal that an AI can actually understand and reason about.
Now, before we go, I want to leave the listeners with a final thought to mull over. You mentioned something earlier that I just can't stop thinking about. This idea of using AI to validate and clean data for other AI, the recursive loop.
The Ouroboros, the snake eating its own tail.
It sounds incredibly efficient, but does it raise a new kind of question, a new risk?
It raises a massive, massive technical and philosophical question. We are building chains of AI dependency.
Right.
Now, suppose you're pre-processing AI, the one that's cleaning the grammar or summarizing the long text, makes a mistake. Suppose it hallucinates a fact while it's fixing a sentence. Or over time, its behavior drifts in how it interprets a rule.
Okay, that's possible.
That error is now baked into what the next model sees as a pristine, perfect input. The big downstream model treats it as absolute truth because it came from the clean pipeline. It has no idea that a fact was hallucinated one step earlier.
It's amplifying the error and hiding its source.
Exactly. And because the whole process is automated, we humans might not be looking at it. We assume the pipeline is working because it's not throwing any errors.
So the provocative question is, how do you validate the validator?
That is the question for the next generation of data and MLOps engineers. We need to build systems to monitor the AI that monitors the data. We need to build checks on the checks. Otherwise, we risk building these incredibly complex, beautiful houses of cards where the bottom card is a subtle hallucination.
Wow. That is definitely something to chew on. We're building a hall of mirrors, and we have to be absolutely sure that the first reflection is true.
Exactly.
Thank you so much for breaking all of this down. This has been a genuinely fascinating look at the plumbing behind the magic.
My pleasure. It was fun.
And to our listeners, next time you see a chatbot give a perfect answer or an image generator create a masterpiece, just take a second to think about the data pipeline, the validation rules, and the JSON formatting that made it possible. Don't just look at the meal on the plate, appreciate the prep work in the kitchen.
Respect the plumbing.
That's it for this deep dive. See you next time.